Welcome to the Stages of Sleep short lecture. So what we're going to do is describe what happens when we actually go to sleep each night. So we're going to talk about the discovery of the stages of sleep, and basically psychologists discovered these different stages by using a machine known as the EEG, or technically the electroencephalograph. So if you remember from Chapter 3 covered this machine which measures brain activity. So just to kind of refresh your memory a little bit, this is where the subject would wear these different electrodes placed on their scalp, and it would send information to a computer to graphically display the brain waves. Remember, when neurons fire, they produce electricity. And so this machine basically would detect the activity of the neurons. In other words, we can discover how active the brain is at any given time and see which areas are more active than others. So psychologists, by using this machine and observing people at night, they've discovered that we do go through different stages. So they would look at the EEG readings. They would also look for things like eye movements, and they would combine that into what we call a polysomnograph. So once again, a polysomnograph is a graph of information which includes the EEG readings, but also the eye movements combined into one. So in other words, this would graph the brain waves and the eye movements. It allows us to observe and monitor those as the night progresses. So thus, by doing so, psychologists have discovered that we go through 4 stages of sleep plus REM, and therefore there are 5 basic stages of sleep. They do have fancy Greek names, but for our purposes in this class, we're just going to number them 1 through 4, and of course REM. However, before we get to that, I want to cover REM because REM is one of the most famous stages of all time, and psychologists are obviously very interested in this particular stage of sleep. So REM technically stands for rapid eye movement, which is pretty self-explanatory. If you've ever seen someone doing this before, this is where they're sleeping, and you can see their eyes darting back and forth underneath their eyelids. So it's kind of an interesting thing that you can observe people actually doing. So what is REM commonly associated with? Well, most of you probably know it is dreaming. You have to be careful with that because we do dream in other stages, not just REM. For example, research has shown that when we wake people up during REM stage, they report dreaming 85 to about 90% of the time. However, when we wake people up during the other 4 stages of sleep, people report that they're dreaming 50 to 60% of the time. So we do dream in other stages. However, when we look at the REM dreams, they are quite different. It turns out that these dreams seem to be more vivid. So they're the really kind of vivid, amazing, fantastic dreams that people often have. And so we think that they're pretty interesting stuff, if you will. Okay, so back to our stages here. REM, once again, is really interesting psychologically because we do refer to it as paradoxical sleep. So a paradox basically means an apparent contradiction. So REM, it turns out, is just that. Even though during REM stage, our muscles seem to be very relaxed in most cases, when we measure people internally, we find that it's not quite the case. So it is a bit of a paradox because outwardly the large muscles are relaxed, but in terms of your brain and your heart rate and your breathing and even your temperature, we find are fluctuating and are very active. So thus it is a paradox because it seems as if we're very relaxed, but internally we are very, very active. So it's a very interesting stage. Okay, so psychologists have measured people during sleep, and they've found that we do cycle through these different stages each night. So the progression is pretty simple, so we're going to go over that. So when we first fall asleep and we've just lapsed into unconsciousness, we would start with stage 1. So stage 1 is thought to be sort of a light stage of sleep. We would then progress to stage 2, stage 3, and stage 4. So that's easy to remember in terms of the progression. Then we hit stage 3, stage 2, and then instead of going back into 1, that is when we would hit REM. So this progression here that you see represents one full cycle of sleep, and on average it lasts about 90 to 100 minutes. So therefore, if you think about it, we would go through several of those each night. So once again, about 90 to 100 minutes on average. Okay, so now we're going to take a look at the stages themselves. So I think it would help to kind of visually see these to get an indication of what's actually happening. So we're going to go to this next slide here. And these would be kind of a crude representation of our EEG readings. So notice if you look up here, when someone's awake, we would expect the neurons to be firing very rapidly. Notice that they're very frequent and close together. So that's showing that a lot of neural activity is happening and they're competing with each other, and a lot of sort of noise in terms of the signal. So that pattern that you see there is very indicating that the person is conscious and awake. Once we fall asleep, we would then go to stage 1, as you can see here. Now notice those waves look a little bit different. They're starting to slow down. So there's still quite a bit of an activity in terms of the brain waves, but they are different when, of course, you compare them to being awake. So it's slightly different, and this is sort of what we would expect in a stage 1 brain wave pattern. We would then progress to stage 2. Now notice stage 2 is a really interesting one because of these sleep spindles. You'll notice that there's these little spikes here, and that only happens in stage 2. So those are called sleep spindles because they look like little spindles. And we've discovered that the amount of spindles you have seem to be correlated with IQ. They've estimated some studies that the amount of sleep spindles and your IQ score is a positive 0.7. So in other words, what that's indicating, a pretty strong correlation where people who have lots of these sleep spindles tend to be pretty intelligent people. In fact, we have connected them to memory. We think they're important for memory storage, but also possibly intelligence. And if you think about it, intelligence would require strong memory skills. Okay, so then we progress on to stage 3. Now notice it's a deeper stage of sleep. So if you look over here on the left, it's kind of showing the comparison from consciousness to deep sleep. So we're going deeper here. And now notice that the waves have completely changed. So this would be typical of a pattern of stage 3. We would then go on to stage 4, a deep stage of sleep. Now look how long and slow those waves are. That's basically indicating that the neural networks are becoming synchronized. They are slowing down and not quite as active in comparison to if you were awake. So once again, the synchrony of the neurons typically occurs during decreased brain activity. As the night continues, we would then hit stage 3 and stage 2, as we said before, and then we go to REM. Now look at the REM waves. So even though this happens way down the line in terms of the cycle, you'll notice that there's a lot of brain activity during this time. So we said REM is associated with the vivid dreaming, and so this shows that the brain's very, very active compared to, say, stage 3 or 4, for example. A lot of activity in terms internal with the brain, and so therefore it's kind of an interesting stage for that reason. All right, so once again, this just sort of demonstrates how we progress through those stages. Please make sure you know the progression of those stages and kind of understand how that sort of happens. All right, so this will conclude our short lecture. Please progress to the next step in the class.